Hello everyone. Welcome to Educate India. In this video, we will see how to process large numbers of files with Python. Before writing the program, we need to check how we get the files to process. If you don't have the files, how will you process them? Next, we will inspect the Parquet files. If you want to know more about Parquet files, the link is in the description. Next, we will write a simple program to process files one by one. Then, we will see how we can use Parquet Meta to filter files. Lastly, using parallel processing we will make our program faster. The problem statement for this video is, how many rooms were booked last New Year's Eve? Files can be stored in multiple places. In this video, all files are stored on disk in the folder name source_data. There are 26,757 files with a total size of 117 gigabytes. Here first 5 files are printed. Data will not always be available on disk. Many times it will be on cloud services like AWS, S3, or on Web API. In that case, we will first see what will be the best way to process the data at that data source. Inspect Parquet. The first thing we will do is inspect the data we have. What are all the fields we have? How to read the statistics for columns. Here PyArrow is used to get the data from Parquet files. First we read the metadata from the file and then we get the schema. We can see, there are 4 fields in the file: property_id, user_id, start_date, end_date. For the problem statement we have to solve. We need the start_date and end_date to check if there was booking on New Year's Eve. Start_date is third column which we get at index 2. To get the statistics we can use meta.row_group0.column2.statistics. For the shown file, minimum start_date is April 11th, 2013 and maximum is April 10th, 2014. I have created these files using the Faker. And if you need the code for it, let me know in the comments. Every file contains the booking for 1 year only. So if December 31st, 2022, New Year's Eve, does not fall in between minimum start_date and maximum end_date, then we can simply ignore that file. We will start writing with the simplest version of code and then later improve it. At the start of program, it's good to import all the libraries used in the code. We import datetime to get how much time it take to run all the files. Next is glob to get all the files which we need to process. Lastly, pyarrow.parquet to work with Parquet files. We can get all the Parquet files in source data using glob.glob, source_data/star.parquet. Next we need to find the booking for specific date. We need to do this for many files, so it is better to write a function for it. Here we create get_booking_count function which will take a file in which we will looking for booking. And second is booking_date. Inside a function we will first create the pyarrow table from the file. Then we get start_date_array and end_date_array from the table. Next we set booking to 0, then we loop for every booking start date and end date. And check if booking_date, New Year's Eve for this problem, falls in between the start date and end date. If it is there we will increment the booking. Lastly, we return the booking. Then we get the total booking to 0. And set booking_date to December 31st, 2022, New Year's Eve. Then we get the booking for all the files using for loop and finally print the booking. The complete code is like this. Here I have set st and et to get the time when code starts and ends and later print how much time the program took. After running the program, it prints total booking on New Year's Eve is 652-8020 and total time taken is 9 hours 5 minutes and 20 seconds. This is a lot of time to process 117 gigabytes data. Although this data is not small, but in real-world applications we will find TBs of data, and this is nothing in compared to that. Question is, can we do something to make it faster? Answer is yes. It is obvious that the slowest part of the code is the get_booking_count function. We have already seen that Parquet also store column statistics in the file, and it can reduce the number of files we need to process. First, we read the metadata from the file, then we will get the minimum start_date and maximum end date. If the minimum start booking date is greater than last New Year's Eve, then this file cannot have the booking for New Year's Eve. Also, if the maximum end booking date is less than last New Year's Eve, then this file cannot have the booking for New Year's Eve. In both cases, we can skip the file. In simple words, we can say if New Year's Eve is in between the minimum start booking and the maximum end booking date only, then we can have the booking for New Year's Eve in the file. The complete code after changes is like this. The total booking is the same as last time, which is 652-8020. But the time taken is significantly reduced to 18 minutes and 38 seconds. This version is 29 times faster than the first version. But is it fast enough? Question is, can we do better? You can pause here and think about it. We know all the files are independent of each other, so we can process them in parallel. My system has 16 processors and this program was occupying just one. We can use multiprocessing to make it faster. To do multiprocessing, I need a function which will be executed by each of the processes. Here I have created the process_files function, which will take part of the total files to process. Inside it, I have set total_booking to 0, which will store the total booking for all the files in a process. Next, we will run get_booking_count for each file in the chunk and return total_booking at the end. We will create a pool of 10 processes. Next, we will break all _files into 10 parts and map them with process_files using the pool.map method. Lastly, we will close the pool and wait for the program to execute. In the end, we will have two functions in the program. First is the get_booking_count function, which will return the total booking for the past date in the past file. And the second is process_files, which will run by each process for the part of all files. Then we create the pool and process 10 files in parallel. Lastly, we print the total booking and total time is taken. Here also total booking is 652-8020, which is the same as the last two programs, but the time taken is 2 minutes and 14 seconds. This version of the code is 8 times faster than version 2 and 244 times faster than version 1. This is very fast, and another point to notice is that we have not used tools to file pandas and Spark. But what if we used pandas instead to get the booking in the file? Let's find out. To use the pandas data frame, all we have to do is to convert the pyarrow table to pandas. We just need to make changes in the get_booking_count function and all code stays as version 3. read_table file. To_pandas method will convert it into a pandas data frame and simply check if the booking data is between start_date and end_date. Later take the count and return the booking. Total booking is the same 6528020, but the time taken is 9 seconds, which is 14 times faster than version 3 and 3568 times faster than version 1. For an experienced programmer, the last version seems the obvious choice, but for a new programmer it is hard. It is easy to start with version 1 because there are not a lot of concepts used and it is simple steps. You import libraries, get all files to process, write a function to process one file, and lastly run the function for each file. Once you have the simplest version ready, you can start optimizing it. There are still many things you can do to make this code better. You can modularize it and make it configurable. There is hard coding in multiple places, etc. Thanks for watching. Please like, share, and subscribe to support us. For any suggestions, please comment.